So when you write an area diagram to find the product of binomials, all you're doing is writing each bracket as either the length or the width of a rectangle and then finding the area of the rectangle. So I'm going to choose the first bracket, 5x minus 6. So it has a 5x component and it has a negative 6 component as the area of your first rectangle, or as the length of your first rectangle, sorry. And the 2x plus 1 can be the width. So I have a 2x here and a plus 1. This is very, very similar to what you see with algebra tiles. And then I'm going to draw lines to separate the elements. So between 5x and minus 6 I've got a line, between 2x and positive 1 I've got a line. And then you just find the areas of each individual rectangle and add them together. So this one is 5x times 2x. So the area of this little rectangle is 5 times 2 is 10. Not very good, 10. 5 times 2 is 10. So you get 10, and x times x is x squared. Then this rectangle here, its length is negative 6. Its width is 2x. So negative 6 times 2x is negative 12x. This rectangle, 5x is one side. The other side is plus 1. So 5x times 1 is just 5x. And the last rectangle here, positive 1 times negative 6, is negative 6. Okay, now to find the total area of the whole rectangle, you're going to add up each of these little rectangles. So I get 10x squared minus 12x plus 5x minus 6. Last step is to combine like terms. So 10x squared, there aren't any other x squareds. I see a minus 12x and a positive 5x. So negative 12 plus 5 is negative 7. So minus 7x. And then just a minus 6 at the end. So your total area is 10x squared minus 7x minus 6. Okay, next question. Same thing here. Choose one of these brackets to be the length of the rectangle, one to be the width. So I'll choose a squared minus 5 to go on top. Just write them a little bit separated so it's easier to draw lines between a squared and a minus 5. And then here we have an a squared and a minus 8. Draw lines between each element, so between a squared and the minus 8 there's a line, between a squared and the minus 5 there's a line. Now you've got 4 little rectangles, find the area of each rectangle, add them up. So a squared times a squared, use your law of exponents, so you get a to the 4th. This rectangle here, a squared is one side, negative 5 is the other, so I get negative 5a squared. Remember, whenever you're multiplying a number and a variable, the number goes in front. Here, this length is a squared. This length is negative 8. So I get negative 8a squared. And last but not least, this length here is negative 5. This length is negative 8. So negative 5 times negative 8, negative times a negative is a positive. You get positive 40. Now to find the area of the whole rectangle, you're adding up each of the 4 little rectangles. So I get a squared plus negative 5a squared, or an a to the 4th, sorry, plus negative 5a squared, so minus 5a squared minus 8a squared plus 40. Okay, so now combine like terms. So we have an a to the 4th. A to the squared terms, I've got a negative 5a to the a squared and a negative 8a squared. So together you get minus 13a squared and plus 40. There's your final answer. Part C. Draw a new rectangle 3p here and a positive 2q. And I have a p on one side and a 9q on the other. Draw lines between your elements to make your 4 mini rectangles and multiply out. So 3p times p, I get 3p squared. 2q times p, I get 2pq. 3p times 9q, 3 times 9 is 27, so we get 27pq. And last but not least, 2q times 9q is 18q squared. If you happen to write one of these as qp and the other one as pq, they're still like terms, because p times q is the same thing as q times p. I just write them in the same order all the time so I don't forget that they're like terms. Okay, add up your 4 mini rectangles. You get 3p squared plus 2pq plus 27pq plus 18q squared. Combine like terms, so the 3p squared is alone. pq terms, we have a 2pq and a 27pq. So I get plus 29pq. And then we have an 18q squared at the end. Done. And last one. So a plus b times c plus d. Draw in your rectangle. We have a positive a and a positive b. On the other side we have a positive c and a positive d. Draw lines in to separate. A times c is ac. B times c is bc. A times d is ad. And b times d is bd. So you end up with ac plus bc plus ad plus bd. Look for like terms to combine, but you haven't got any like terms, so this is as far as you can get, and that will be your final answer.